So I think I have talked before sitting in this place. This is my village home, and in about 24 years ago, I started coming here. I built all the houses, and I started to do a new kind of genetics, which I did in this village for last 24 years. So in summary, everybody knows and have an idea about genetics. These days, people are more caught up with GMO. What is GM crop? Some people say gene editing, etc. So these are new things that have come into the public space, and people are always talking about it. GM crop, gene editing, and genetics is not the same thing. I am talking about genetics of Mendel, when Mendel started the genetics. Before that, Darwin, without knowing much about genetics, was talking about genetic variation followed by selection, evolution. Everybody knows about these things. And historically, to make a long story short, a group of scientists such as Fisher, such as Dobzhansky, they kind of combined Darwin's idea and Mendel's idea and gave rise to what we call genetics, the new synthesis, many people call it. I went to the US at the age of 23 without knowing anything about genetics or biology. I just had a high school biology education, and I studied chemistry in Dhaka University, and then I got a scholarship or assistantship in University of Oregon, which is also the place for Institute of Molecular Biology, which turned out to be a very important event for me. So I went to Oregon, Eugene, as a PhD student in Department of Chemistry, and I found that I have the ability to join the Institute of Molecular Biology as a PhD student. And that institute had very towering figures of molecular biology. For instance, there was Frank Stahl was there, Aaron Novick, who used to be the graduate student of the great physicist Leo Szilard. Aaron Novick was there, who founded the institute. And so one day I was in Bangladesh without any knowledge of biology. 1 week later, I was in close proximity to the world's topmost geneticists and founding members of molecular biology. So that completely changed my perspective about everything. After all these years, several things stand out. So I had a very rural upbringing over here. You can see surrounded by nature. You can hear the sound of rain. And I had a very simple-minded view about nature. We used to collect flowers. We used to collect leaves. We used to observe the shape of the leaf, look into the petals of the flower, take a flower, count the petals. So this is how, without realizing, I have been indoctrinated into natural science or botany or kind of a very fundamental aspect of actual science, which I did in the childhood without realizing it. And then I went to Dhaka University, where in chemistry department, our teachers were very nice and everything, but it was very structured. So I couldn't really mix with the students, couldn't mix with the teachers socially. There was always this distance and this Asian idea of respect. So you have to only talk when you are talked to. You have to say, kind of stand in a very respectful way and not say anything. And when the teacher says something, you have to vigorously nod your head and agree to everything he is saying, and you should say, yes sir, yes sir. So this is the kind of culture that I was used to in Dhaka University. And then when I went to Oregon, I suddenly found that it was like my old village. Everybody knew everyone, and I was literally, Frank Stahl was pouring a cup of tea for me, and he was giving me some soup. He used to come with a pan with the soup, and he would give me some soup, and others in his group. I was not in his group. My direct PhD supervisor was Jerry Smith, a very sharp, smart young scientist who came from Boris Magasanik's lab of MIT. And as it turned out that I would later go to MIT and meet Boris as well. So when being in Oregon and Institute of Molecular Biology in that atmosphere, I was like, it was for me like coming home in many ways. So there was a village-like atmosphere. There was an atmosphere that things are possible, things are easy, and there was an invitation to delve into the science in an obsessive way and not a 9-to-5 job. So I picked up that kind of work ethic, which I still have till today. So I was very lucky in that atmosphere in Oregon. I could make a very major discovery almost as soon as I joined Jerry Smith's lab. And that was to discover the gene called REG-D, which is part of the REG-BCD. Now it is called REG-BCD. Before my intervention into science, it was called REG-BC. So that REG-D gene, which astonishingly was invisible to the top scientists, including very famous biochemists from Berkeley, UC Berkeley, were studying. Nonetheless, they did not have a clue of that gene. So I applied a very simple genetic trick to ferret out this gene, and so the REG-BC became REG-BCD enzyme, and I kind of got a seat in the table with the scientists. I was invited to Cold Spring Harbor meetings. I could talk to people like Frank Stahl, almost like an equal, and other people like Charlie Redding and Bill Holloman. Those people, those names comes to mind. Hamilton Smith, who got the Nobel Prize for discovering restriction enzymes, he sent our paper to PNAS. So that taught me, that told me that I could be, although I had no formal education in biology. I grew up in Bangladesh in universities which are probably not rated at the top of the world, but they were in fact very good, because they did gave me enough education to go and kind of mix with the US trained students. And I was in fact the first person in my graduate school batch to come up with a PhD, because I did everything so quickly. I did very important work, several papers through Proceedings of National Academy of Science, discovering of a new gene, invitation to Cold Spring Harbor grand meeting organized by Jim Watson on recombination at a DNA level. So I was discussing things like how the enzyme goes through the DNA, unwinds and rewinds the DNA, and meets a DNA sequence, an octamer called GC, TGG, TGG. So this is a very exciting phenomenon where an enzyme goes through the DNA, meets a particular DNA sequence, and the enzyme changes. So it's a DNA-enzyme interaction, changing the nature of the enzyme. Really, really top level molecular biology. And in fact, this work, after I initiated the REG-BCD work for the first time, it became a part of the field, and finally it was a cover story when the REG-BCD structure was determined. It was a cover story in Nature. And my PhD supervisor, Jerry Smith, told me that tens of millions of dollars of grant were obtained because of the REG-D discovery and the new excitement around REG-BCD enzyme and its relationship with chi-site, its ability to initiate DNA recombination, which these days are called CRISPR-Cas9 derived gene targeting or gene editing. In those days, we called it one-step gene disruption or homologous recombination. So these tens of millions of dollars were initiated through my solitary work, as it became part of the mainstream science, done by other people. I did not get this money, but I would like to say at the end of my career that this was a contribution of a Bangladeshi person, a person of Bangladeshi origin, into international science. It was not a case of Bangladesh receiving money from the US. It was a case of Bangladesh giving something to the US science, because what I gave, what I could give, is also what Bangladesh gave, because I was created by Bangladesh, so to speak. So I would like to say this. This is very important to say, because the way the people are being profiled, a Bangladeshi person holding the green passport when he goes to a place like London or Paris or Rome, typically he is not allowed in. In order to get a visa, it's an excruciating process. He has to prove that he has a house in Bangladesh worth millions of dollars, so he has a reason to come back. Even to Australia, my other country of which I am the citizen, puts extraordinary barrier to the entry of a Bangladeshi into Australia. He does not put up similar barrier for the entry of a US citizen or a German citizen or a French citizen. But Bangladeshis are targeted in this way. So me being a Bangladeshi feel this pain, although I don't encounter this because I travel with an Australian passport. But I encountered this profiling in the international borders. And this is completely opposite to what people say in the United Nations. They will say, oh, the earth is one place, we are for everyone, we love humanity. But when these kind of issues come, movement of the people, they put up barriers. So my whole life I have encountered it. I have been profiled simply because I am of Bangladeshi origin. I have been subjected to Islamophobia because I have the Muslim name. However, I have endured it. I have not protested against it. I have simply worked very hard in order to prove that I can contribute to science. And I have also proved that I can actually give to America. I have not taken anything from America, but I have given tens of millions of dollars of intellectual property to the United States of America. So after this REC-BCD work, which I did in the Institute of Molecular Biology, and then we moved to Fred Hutchinson Cancer Research Center, where I continued to do the work in Jerry Smith's lab. REC-D was discovered. Just when it became a big bonanza of activity, I shifted to another subject, which was yeast recombination. I got a National Institute of Health fellowship to go to Research Triangle Park in North Carolina in Mike Resnick's group, who had earlier studied yeast biology with Seymour Fogel in UC Berkeley. And I continued to work on gene-targeted recombination in yeast. And in yeast, I concentrated on studying sister chromatid recombination. So I made DNA constructs so that sister chromatid recombination could be studied as opposed to normal homologous recombination. That work was constituted learning all about yeast genetics, attending yeast meetings in Cold Spring Harbor. The work took a long time to set up all the constructs and everything. By then I had decided that I want to work on plants. I went to one of the Cold Spring Harbor yeast meetings, and I met Amal Clark and Jim Hicks and Jeff Southern, who were previously, particularly Jeff and Jim, were students or postdocs of Ira Herskowitz, which is one of the leading, probably one of the most important geneticists ever, who was a professor in University of Oregon. And I took my first genetics class actually from Ira. Anyway, Jim showed me some little weed growing in the Cold Spring Harbor campus and said this is Arabidopsis, and future is now Arabidopsis in plant biology. So that was probably 85, 86. And I immediately decided to work on Arabidopsis because I wanted to work on plants. So by connecting with Ethan Signal, who was in fact the mentor of Ira Herskowitz, and people like Fred Osabal and Nancy Kleckner, who have become absolutely linchpin scientists in US. But their supervisor, their PhD supervisor was Ethan Signal, who is one of the, you can call him one of the founder of modern molecular biology, because he and Jonathan Beckwith did world's first cloning experiment, where they put in the phage Phe80 into the E. coli chromosome and Phe80 excised, and that was the world's first case of gene cloning without any restriction enzyme. So this is Ethan Signal, absolutely legendary person. I connected with him, and together we wrote a grant to a platform called Life Science Research Foundation, which was an organization started by Don Brown, and it used to give research grant to early career postdocs or postdocs who wanted to move into another subject. So anyway, to make a long story short, I got that grant, which is a very competitive grant, which allowed me to go to the LSRF, Life Science Research Foundation retreats. And I was so by that time I already started working on Arabidopsis in Boston. I was in MIT Biology. I was part of the Boston area Arabidopsis group, having weekly meetings with people like Jerry Fink, Fred Osabal, Howard Goodman's lab in the Harvard Wellman Center, Harvard MGH, Harvard Mass General Hospital, Massachusetts General Hospital, Wellman Center, level 9, I still remember, was the center, epicenter of Arabidopsis genetics, because Fred Osobel was there, Howard Goodman was there. So I participated in this atmosphere, and I was given the job of, given some mutagenized Arabidopsis seed by Fred Osobel. And he told me, you take over the whole field of male sterility. You find all the male sterile mutant. So this was almost like the time where you went to a new continent and you divide the territory among yourselves. So this scientific territory was being divided among these Boston area people. And I was given the job of working on male sterility. So I came back to MIT Biology, our old-fashioned department, Building 56. I converted Mary Lou Pardue's Drosophila cabinet into plant cabinet, and I started looking for MS, male sterile mutant. To make a long story short, I found tens of male sterile mutant. I probably found all of them. It was saturation mutagenesis, male sterile, female sterile. Ended up mapping them, molecularly cloning many of them, but only after I went to Australia. So how did I go to Australia after being in the US for 10 years? In one of the LSRF retreats, I met, obviously I was meeting top people like David Botstein and all these people, absolutely, landmark figures of US science. And Don Brown was the nicest and most noble of them all. He was very concerned about my welfare and where I would be, etc. And when I complained to him that yes, MIT biology is good, but Boston area is such that we don't have a lot of land for doing plant genetics, he advised me to come to Australia because he had just met Jim Peacock. He came to Canberra, he saw the setup of CSIRO division of plant industry, and he spoke very highly about Jim and Jim's group and Liz Dennis and others, and said that, oh, you should go there, So because of his advice, I wrote to Jim and Liz, and they invited me to go to Australia. So in year 1988, in April, I remember, March-April period of 1988, me, and by then, of course, I was married, and there was Tulip, my wife Tulip, and myself, we went to Australia. I was invited to go give a seminar in CSIRO division of plant industry. I absolutely loved the city of Canberra, the University House where I stayed. The whole atmosphere I loved a lot. And I decided, and MIT was finding ways of keeping me by applying to Labor Department to get an H1 visa and all those things. Because I was funded by LSRF, and they had a job for me actually. And Ethan was very supportive, and they even advertised in Boston Globe my job in a way that only I could qualify, that sort of thing, writing very specifically the advertisements. And I even went to see Senator Kennedy and recruited his help in getting this J visa to H visa conversion, which is very complicated. And the senator has to say that his presence is needed in the US and that sort of thing. So it was always this usual process in the US. H1 visa and H1 transitioning into residency, green card, and so on would have been the process had I stayed back in the US. But I decided to move to Australia because I liked Australia a lot. It was a new country after being in the US for 10 years. It was a very exciting place, and I loved it. I loved the CSIRO plant industry, Jim and Liz and all this vibrant group, Karam Singh, I remember meeting these members of that group. So that was a fateful decision, fateful in a positive sense, that I decided to just move to Australia, which happened between the year 1988 and 89. Tulip also got a job in the Australian Public Service. I got a job in CSIRO. And by 1989, I was totally settled in Canberra, CSIRO division of plant industry. And initially, I was recruited on agri-genetics money to do maize transformation. So because of my wide interest, I had worked a bit on agrobacterium I knew how agrobacterium transfers DNA into plant because I was in Ethan Signer's lab, who was the father of rhizobium genetics, and Fred Ozabal was his student, and so I picked up all the agrobacterium and rhizobium genetics from them. And indeed, one of the agrobacterium strains that I got from Fred Ozabal and sent over to Australia became very instrumental in doing cotton transformation in Australia. A gene called a variant or a strain of agrobacterium called AGL1. And I know, I remember I wrote AGL1 in a particular way, and I found that everyone in plant industry was calling it ugly. So it's not ugly, it's AGL1. And that played a very pivotal role in cotton transformation in those days. Anyway, I stayed in CSIRO division in plant industry from 1988 till 2008. In these 20 years, I developed Arabidopsis in CSIRO in a big way. One day there was no Arabidopsis in CSIRO plant industry. 2-3 years later, there were dozens and dozens of papers, invitation to meetings. And I wouldn't say entirely, because other people were also on flowering and other things, but certainly my own work and the fact that I took all the Arabidopsis mutant strain that I had developed over to Australia played a very important role in the signature of plant industry becoming a leader in Arabidopsis work in the 90s. What comes to mind is the gene called AMP1, which I had picked up while I was in Boston. I had looked for cotyledon number mutants. I got AMP1. I got all the male sterility genes and cloned many of them in collaboration with students over in Australia. And by using my knowledge of male sterility, I devised a screen to get seed without fertilization, or FIS, fertilization independent seed, which became the landmark work done by me in the 1990s. So I did a landmark work in 1980s, which was Reg-D and recombination. Did a landmark work in the 1990s called fertilization independent seed, which I did for Australia. The first one I did for America. The second one, FIS, I did for Australia. So again, I want to emphasize that I was a person of Bangladesh, studied in Bangladeshi village. I went over to the US, learned the craft of molecular biology, donated my 10 years of work to the US Science, according to my PhD supervisor, worth tens of millions of dollars in research grant. Then I, with all that knowledge and literal genetic material, I moved to Australia, developed Arabidopsis genetics for Australia as well as other work, and kind of donated that or participated in that work for the science of Australia. So now you go look for this work. It is seen as US science and Australian science. Nobody would call it Bangladeshi science, but behind it there is a very powerful Bangladeshi person, which is me. And by the time 20 years later, by year 2008, and in fact starting from year 2000 actually, I started to think that I ought to do something for my birth country, for Bangladesh, because I felt that I had done enough for my career or moving ahead into the world, and I was not interested in personal upliftment anymore. I was more interested in following the legacy of the long tradition of my family, my area, Kanihati, and I knew that my father was also like that. He gave up all his life for the betterment of the area and the people. And I believe that this kind of altruism and this kind of attitude, this kind of a sense of calling, quote unquote, is a hereditary trait. I felt that very strongly. And I was almost compelled to, because everybody was surprised when I left everything, basically left the job. I looked for a way of how to leave the job in CSIRO. And Jim Peacock had stopped being the head of plant industry. There was another guy there who I don't think understood anything I was doing. He called me in a very official kind of meeting and asking me all these questions, which greatly annoyed me. So I was really annoyed also in a very big way with the new group of people who had come after Jim. But I was also more stimulated to leave Australia not permanently because I was an Australian citizen. My wife was a senior member of Australian Public Service, but I wanted to come and do things for Bangladesh, which is exactly what I did. Fortunately for me, I was introduced to a guy called Graham Robertson, who is the brother of the most eminent barrister of contemporary times, Jeffrey Robertson, QC. As it turns out, the other day we were in Canberra and Jeffrey came and gave a big talk. He's a major intellectual public figure in Australia, of Australian origin. And his brother Graham is an entrepreneur based in Indonesia and Singapore. And he was very excited about my work in rice. Because by then I had started to work on rice in Bangladesh and the news had spread. So Graham told me that why don't you introduce rice to Africa and we'll support you. So he set up a company called Vita Grain. I took rice to Mauritius and Tanzania and Mozambique. Worked with Graham from 2008 to 2018 with the Robertson's family business and maybe the chief scientist. It was very exciting time, and that is also the period I developed my own work in Bangladesh, in my village. I restored all the cottages dating back to like 14th century. We have been in, my family has been in this area. So I fixed everything. I started to work in the field, targeting a very important concept, which I will talk about in the next chapter. Thank you.